This question belongs to Engineering Mathematics subject and was asked in GATE CSE 1989. It is related to planarity and planar graphs. So the question asks, which of the following is a planar? We are given three graphs G1, G2 and G3 and we need to tell which of the following graph is a planar. So what is a planar graph? A planar graph is a graph which can be represented on a plane. So a planar graph is a graph which can be represented on a plane. Represented on a plane means represented on a sheet of paper, you can assume. It can be represented on a sheet of paper such that two edges, any two edges intersect only at endpoints, which means we can have two edges intersecting like this. This is planar graph. We can have this, but two edges can't intersect in between. Like two edges can't intersect in between. This is not a planar graph, but this is a planar graph. As we have a vertex in between, so no two edges is intersecting from between. They are meeting only at the endpoints. So we have a very important theorem for the planar graphs which will help us in answering this question. If m is number of edges in a planar graph, it's a corollary and it's a corollary. If m is the number of edges and n is the number of vertices, then for a planar graph m should be less than equal to 2n minus 4. So let us verify this for all these graphs. So here, what is the value of m? So m over here is 1, 2, 3, 4, 5, 6, 7, 8, 9. And what is n? N over here is 6. So is 9 less than equal to 2 into 6 minus 4? Is 9 less than equals to 8? No. So it's not a planar graph. Is this a planar graph? Let us verify m. What is the value of m over here? 1, 2, 3, 4, 5, 6, 7, 8. M is 12. What is the value of n? Value of n is 8. Is m less than equal to 2 into n minus 4? 12 is less than equal to 16 minus 4, 12. But if we are able to verify this, then it doesn't mean that the graph is planar. If this is not verified, if this condition is false, then it means if this is false, then it means graph is not planar. And if this condition holds, if this condition is true, then G may or may not be planar. May or may not be planar. And for that, we need to verify it by drawing the planar equivalent. So we can draw the planar equivalent of this one as like this. We can draw the planar equivalent like over here. We can have like this, an edge like that, and edge like that. So this is the planar equivalent of the graph G2 with no two edges intersecting from the middle. So G2 is planar. Let us find the value of number of edges and number of vertices for G3. So number of edges over here are 1, 2, 3, 4, 5, 6, 7, 8, 9. And number of m and n. And number of vertices over here are 1, 2, 3, 4, 5, 6. So 9 is less than equal to 2 into 6 minus 4. 9 is less than equal to 12 minus 4, 8. This is false. So G3 is also not planar. G1 is also not planar. So the answer is G2 is planar. And we can also see that G1 and G3 are isomorphic to each other. So if G1 is not planar, then G3 is also not planar. So the answer is G2.